4.4, 4.5, day 2. Today we are going to draw lines of best fit. So yesterday we did our scatter plots. And remember, if you have a scatter plot, it is representing data, right? Numbers, right? But they don't necessarily lie in a nice straight line. But that's okay, because sometimes that doesn't happen with real life data, at least actually most of the time it doesn't. So we are going to practice drawing a line of best fit today. What that means is this line isn't perfect, right? But it reasonably represents what we're seeing. So a line of best fit is a line drawn on a scatter plot that is, I don't remember what word I wanted to put there, I'm not gonna lie to you. Huh? Oh, yeah, because I mean, I thought this is 10. I'm so slow, right? Representative, that's how I think about it. Because it's a big word. Okay. All right, so a line of best fit is a line drawn on a scatter plot that is, that line, that word doesn't really make sense, but that is okay. That is representative, or that represents, here, let's change that. I don't like that wording. We're gonna change, yeah, get rid of that is, that represents most of the data. There, I like that wording better. Where? Oh. A line of best fit is a line drawn on a scatter plot that represents most of the data points. So finding a line of best fit, we have a 4-step process. First is to make a scatter plot of the data. Next is to decide if the data can be modeled by a line. Not everything can be. If there's no correlation, are you going to be able to draw a nice line? No, but if there's reasonable positive or negative correlation, it might work out. Jaden, you ready? You ready to get started? Corey, you got a pencil? Okay. Okay, then you draw a line that appears to fit the data closely, aka just do the best you can to do something that I almost feel like try to aim for the middle, right? A good rule of thumb to use is to have about as many points above as below the line, because it's not going to go through every little point. So try to have as many points above as you do below. So try to make it as close to the middle as you can. And then you write an equation using 2 points on the line. So pick 2 points that actually fall on the line and then write an equation with those. It won't be perfect, but it will be reasonable. Where? Equation. Oh. Oh yeah, well it was sloppy and I erased it and put it back. All right, writing equation of the line of best fit. So step 1. Okay, so then once you get there, right, now we're at our writing an equation part, which we've done, but again, it can kind of be a long process, so I want to refresh. Once we have the line drawn, you pick 2 points on your line. Then you find the slope between the 2 points. Then plug the slope and 1 point into the point slope formula. It's because the example kind of takes a bit of time, and I want to have time to work on our activity, hopefully. All right, so that's it. We're going to plot our points, try to figure out a reasonable line that goes through them, and then do our best to write the equation of that line. So Now really the only way to learn this well is to practice it. So use the data tables to draw and write the equation for the line of best fit. So the first situation we're looking at says the table shows the total earnings, Y, in dollars, of a food server who works X hours. So what this table shows is at 0 hours, she makes $0, right? At 1 hour, they make $18. At 2, 40. At 3, 62. At 4, 77. At 5, 85. And at 6, 113. Now, this is not going to be a nice straight line when we graph it. Can anyone maybe think of a reason why this would not be a nice straight line if you're a food server making money, Lynn? Yeah. Exactly. That first hour they made $18, right? But then by hour 2 they had jumped all the way up to 40. Lynn said maybe it has to do with the number of people that come in. Absolutely. If you're a server, you have like a base salary, but isn't a lot of your salary tips? So couldn't your tips vary throughout the day? Yeah. So it's not going to be a nice straight line, right? Like if you work a standard job and you make $8 an hour, right? That's going to be a nice straight line. Oh, I need that. All right, tell him to tip me $300. Anyway, so yeah, it can vary, right? It's not like your standard job where you would make $8 an hour. Everything varies based on tips. So what we're gonna do, our step 1 is to make the scatter plot. I gave you a little chart here. X is on the bottom, Y is on vertical here. X is the number of hours, Y is her total earnings. So what we need to do first is, does our graph have any numbers on it? No, we should probably put some numbers on it, shouldn't we? Now when you do this, I try to do my best to give you ones that are sometimes pre-numbered, but sometimes it depends on your data, right? So take a look at the X. For the X, don't we just have to get up to 6? So could we count, would it fit to count by ones down here along the bottom? Yeah, so let's count by ones there. So I'm gonna say this first line, I'll do it in a color so you guys can see it. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just gonna go through and number all of them. Do you guys need a darker color or can you read that? Okay. All right, now for the Y's, we got to get all the way up to 113. So is it going to make sense to count by ones? No. Does anyone know maybe a strategy we could use to figure out what we could count by? Okay, tens. Aaron, what's this? Oh, you could use the break. Yeah, maybe use a break. Lynn, you had your hand up. Okay, by 50, well, 50s might get a little big because if you go, this would be 50, 100, 150, and then, yeah. So someone suggested tens. Let's see if tens would work. 10, 20, 30, 40, 50, 60, 70, 80, 90. No, is that going to work? Okay, by 20s. So 20. Well, so I'm going to go ahead and tell you, you could use a few different things. Last year, I did mine by 15s. I did mine by 15. So do you want to, I think that'll fit. So let's do that. Let's do 15. So that means this first line is 15. And then you go up another 15 to 30. And then another 15 to 45. Another 15 to 60. Then 75. Then 90. Then 105. Oops, sorry. I clicked something goofy. Yeah, and then 120. And then we could actually, you can keep labeling if you want, but at that point, will everything fit? Yeah. All right, so let's now graph our dots here. So I'll do this in black. So our first dot is 0, 0. That's down here at our origin, right? 0, 0, put a dot there. Now we have 118. So go over 1 and then up 18. Now here's the thing. You guys have a tendency to like when something's a nice perfect point, but are these going to be nice perfect points? They're going to require a little estimation, and that's okay. I'm not expecting it to be perfect, but if this line here is 15 and the box up above is 30, do you think I should be closer to the bottom line or closer to the top line? Probably closer to the bottom line, right? So I'm just going to go a little bit above the 15 and put my dot there. Again, doesn't have to be perfect. Okay, then 2 and 40. So go over 2, and then there's a line there. I could either do 30 or 45. Do you think I should be closer to 30 or 45? Yeah, a little. So I'm just going to go a little bit under the 45. All right, then at 3, it's 62. So 362. How do you think I should graph that? Yeah, up to 62, right? But is there a line at 62? Oh. Yeah, I gotta go just a tiny bit above the 60, right? Because it's 62. So I'm just gonna go a tiny bit above 60. So far, it's looking pretty linear. At 4 hours, it's 77, so go over 4, and 77 is just gonna be a tiny bit above 65. And then at 8 or at 5, go up to 85. That's just gonna be a tiny bit above my last dot, because 80 or 85 is still between, or I'm sorry, I'm gonna go a little bit higher than that. Because isn't 85 still between 75 and 90? So I'm just gonna go a little bit below here. Again, estimate it the best you can. And then 6 is 113. So here's 105. Here's 113. I would say that's pretty close to the middle, right? I think that's almost right in the middle. Okay. So is this a nice perfect line? No. Is it okay that it's not? Yes. Because it's just simply not going to be. Okay, so we have accomplished step 1. We made our scatter plot. Can the data be modeled by a line? What do you think? Well, it's not going to be perfect, but could we kind of draw a line of best fit to represent it? Yes. So this it's not asking you, is it perfectly linear? It means, is it going in a general, like upwards or downwards direction? And I would say yes. So yes, it can be. Yeah, draw a line of fit. So here's what we're going to do. When you draw a line of fit or a line of best fit, we are going to do our best. This is when you need to grab your handy dandy ruler, and you are going to draw a line that goes through this. Now, it's important that I draw a reasonable line, so here's what I'm going to do. I'm actually going to get out my line tool here. Shapes, because I do not want to confuse you with a bad line. Okay, so let's see how we can I'm going to kind of model it for you and then try to walk around and help. So when you're drawing a line of best fit, I would use your ruler to kind of like start to gauge where you might want a line. So pay attention to this, guys. If I draw a line here, does that look reasonable? No. If I draw a line up here, does that look reasonable? No. I should try to get it through at least some lines, right? Or some of the dots, right? Now, if I draw it, let's say here, do I have as many points above as I do below? If I draw it right here, do I have as many points above as I do below? No. Is it okay? Yeah, but don't I have several points below? Okay, so I'm going to try going a little bit lower. What if I more draw it like here? Does that look pretty reasonable? Yeah, because if you take a look, I have 1 point above now and 1 point below. So let me make this a little bit thicker so you guys can see it better. Okay, there we go. That way you can see it. And there it is. So I would try to draw your line as closely through that as possible. So people at home, we're just kind of trying our best to estimate a good place to put this line where it goes through as much data as possible. So we should grab our rulers for this. Oh, I've got a ruler. Use it. It's not a line, that's a, I don't know, that's a, I don't know what that is. All right. So there's that line. All right, now, now we've done step 3. So we're good with that. Now, step 4 says pick 2 points on the line and use them to write an equation. Today we're gonna pick the same 2 points so that way we have the same graph going on, okay? So let's pick 2 points. Take a look, what are some points that this line actually, like, that you can see that it goes through? Okay, it definitely, yeah, sorry, someone at home was about to say something. What was that? Yeah, okay, it definitely goes through 0, 0. It goes through 118 and 240. It kind of goes through 4 in the other one and then 6, right? So I could really pick any of these to write an equation with. 118 and 240? Sure, let's do that. Because those seem like okay numbers, right, to use. Yeah, I agree. Let's use, so we are going to use 118 and 240 so that we're all using the same points, okay? So these are going to be the 2 points I picked. Now to make sure that I know exactly which ones I'm using, I'm going to rewrite it down here. I'm going to use 1, 18 and 2, 40. That's the data I'm going to use. Okay, now if you go back up to writing an equation of a line, step 1 was to pick 2 points on the line. We did that, right? Step 2 is to find the slope. Can I now find the slope? Yeah, let's find the slope. So remember, when we find our slope, we do m equals y2. Sorry, it's being really glitchy. It doesn't want me to write over here for some reason. Okay, so m equals y2 minus y1 over x2 minus x1. So how should I plug this in for my slope? What should I do with my y's? Subtract them. Okay, so that would be 40 minus 18 over, and then on the bottom I do what? 2 minus 1 equals. Okay. Jaden, you awake? You writing any of this down? 40 minus 18. I think that's 22. Yep. Cool. So we got 22 over 1. How can I rewrite 22 over 1? Just 22. Okay. So that is my slope. Now take a look at your steps. I now found my slope. I've done that. I did step 2. Step 3 says plug the slope and 1 point into the point slope formula. So I now need to take my slope, which is 22, and 1 point. Does it matter which point? No, pick one that you think looks easier. Let's use 1 and 18. Take my slope and my point and plug it into point slope. So remember, point slope is y minus y1 equals m times x minus x1. So that's going to be y minus 18 equals m, which is what? What m did we find? Yeah, 22 times x minus x1, which is just 1. Then what do I do now? Yeah, we got to drop the y minus 18 and distribute. So we're going to have y minus 18 equals 22x minus 22. And my final step? Add the 18 to both sides. Good. I'm going to do that over here because I'm kind of out of room. So y equals 22x. And yeah, negative 22 plus 18 is negative 4. So that is my answer to this part. Y equals 22x minus 4. Now to kind of tell you guys how much this can vary depending on what points you put. Last year, we picked the coordinates 118 and 477, and our equation was y equals 19.67 x minus 1.67. We picked some nice numbers, didn't we? Now, will decimals sometimes happen with this? Yeah, but are you allowed to use a calculator? Yeah. Yes, you're always allowed to use a calculator. So, what does the slope of the line of fit represent? Now, this is a question you'll see occasionally. What this is asking you is if you were this server, if you were this person, what does the slope mean to you? So think about how we wrote our equations before when we would have like a service fee and maybe then like a per hour price or something. This means this person is making $22 per hour, okay? And their starting pay was negative $4. Now, does that necessarily, are you actually going to start with negative $4? No, but isn't this line just an estimate? Yeah, but is it negative 4 and 0? I mean, they're not, yes, there's a difference, but isn't this just an estimate of the data? It's not going to be perfect, okay? So what does the slope mean? Well, the slope here is 22. That means they make $22 per hour. Doesn't per mean multiply? And are you multiplying the 22? Yeah. And then what does the y-intercept represent? Well, that's her starting pay, right? Which, like, I know it wouldn't actually be negative. Again, this is an estimate. How we're going to write that is that this represents how much they made. Well, it wouldn't be in how many hours did you say? Well, so not necessarily 6 hours. If this is their starting, have they worked yet? If this is how much like they're starting at, then have they even begun work? No. So this is how much they made before she started work. So how much they made before they started, or you can say when they worked 0 hours or something. It's like the starting. I know, it's like the starting price. Okay. Or how about we put, would you prefer if we said it's their starting pay? Would that make more sense? Huh? Okay. That would work too. So it's how much money they made, or I'll just say how much money they started with. So how much money they started with. Does that make more sense to you guys? Because it's like a fee, right? Like when we would pay an initial fee. So that's how much money they started with. Okay. All right. Let's see. We got one more example, I think, on the back, right? All right, let's try this one more time and then we'll take a little break and work on our activity. So the table shows the weekly sales of a DVD and the number of weeks since its release. So, people online, how are we doing so far? I know that this can be a little tricky, but do your best to follow along.
Yeah.
Okay. Yep. Yeah, it's a little tricky. Okay, so our first step is we are going to do what? Take a look at the front page. What is our first step? Plot the data. So in order to plot the data, do we need some numbers on our table first? No, you do not have to reorder them. So that's a good question though, because since it's a scatter plot, it doesn't really matter what order the data is stated in. Okay, so look at the weeks. I have to go up to 8, right? Will that fit if I go by ones? Yep. Yeah, so let's just count that by 1. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I just labeled the bottom. And then what's the highest number on the Y part? 19. Will that work if I count by ones? No. Shall we maybe try by 2? Okay, let's try 2s. This would be 2, 4, 6, 8, 10, 12, 14, 16, 18. Yeah, it'll just go a little bit above that, right? So let's go by 2s. So this is 2, 4, 6, 8, 10, 12, 14, 16, and 18. And keep in mind, this is in millions. So like 2 million, 4 million. You don't have to write all that. Well, because it's DVD sales, so it's like a profit. People at home, do you understand how we labeled our table? Okay. So now we're going to just plot these points. So at 1, it's 19. So I need to go above the 18. All right, like halfway, like right there. Okay, keep in mind all your odd numbers will be in between. At 2, it's 15. So go up to 14 and then go halfway between 14 and 16. Does that make sense, guys? Okay. And then at 3, that's 13. So go halfway between 12 and 14. At 4, that's 11, halfway between 10 and 12. At 5, it's 10. At 6, it's 8. At 7, it's 7, right? So go halfway between 6 and 8. And then at 8, it's 5. So that's halfway between 4 and 6. It's almost straight. It's almost. It's not quite. Yeah. Now, well, let's think about that. Isn't this representing the weekly sales of a DVD, right? So let's not even, people don't really buy DVDs anymore. Let's say it was a game, okay? A newly released game. What's going to happen that very first week that game is released? Everybody's going to buy it, right? Everybody is going to buy it. But by week 8, are as many people buying it anymore? No. So wouldn't that make sense with kind of our downward trajectory here, right? So yeah, it starts up really, really good, right? Because it was just released, everyone wants it. But then by week 8, it's making a lot less money. Does that kind of make sense, guys? That's what's happening here. It's still a lot of money, I know. Girl, me too. So let's now let's draw our sorry, I'm getting all tongue tied here. Go back up to your steps. Step 2 is decide if the data could be modeled by a line. It's not a perfect line, but could we do a line of best fit for it? Totally. So let's now draw that line. Yes, please use your ruler. So I'm even gonna get out my little line tool again. It does not necessarily have to go through the 19. We're probably going to need to play around with it a bit. Now, should this line point up or point down? Down, right? So let's kind of see where we could maybe put it. Would this make any sense? No. Would this make any sense? No, we need to get it through at least a couple points, right? This looks kind of reasonable. Let's see, we might need to adjust a little bit. Right now we have 3 points above, we got 3 points below. I feel like it needs to go, I don't know, I guess this is okay. What do you guys think? I think I like. Now, if I do it like this, do I have 2 points going through it? Can you guys see the 2 points? When you draw your line of best fit, make sure it at least goes through 2 of the lines. Let's draw it through here so that we can use these 2 points to calculate. Okay, so let me make this a little bit bigger so you can see it better. Oops, wrong direction with that. Yeah, it should go through, so the way you draw your line, guys, it should go through 5, 10, and 6, 8. Here, I'll come around and help. So, guys, people, well, I'll come look. Well, yours might just be a little bit different. Let me look. So, people at home, do we see where I drew my line? Let's see. It could even just be a difference with where your plots are. Does it matter if we use dots to make the equation more? Okay. Does it really even? Because I was doing it and I think 119. Oh yeah, I'm erasing that. It's just that you're equation. Yeah. Don't mind me, and I can check it. Okay. So we now have our line. Let's pick 2 points on it. I can clearly see that it goes through these 2 points, right? Yeah, 5, 10, and 6, 8. So that's these 2 points. Okay, so we have plotted our line. We have picked 2 points. What do I now need to find? Look at the front if you need to. Yep, we are going to find the slope. So my points are 5, 10, and 6, 8. I'm just rewriting them down here so we can see them a little bit easier. Oops, what did I just do? It is. I don't know. Sorry, I don't know what happened here. There we go. Okay, there we go. So now let's find our slope. Remember that it's just like being glitchy. I did not draw my y like that. Okay, so we do m equals y2 minus y1 over x2 minus x1. Somebody help me calculate my slope here. What do we do? Jake? That's okay, Jake? Yeah, 8 minus 10 over 6 minus 5. Good. All right, 8 minus 5 is what? All right, I'm sorry, 8 minus 10 is what? Negative 2. 6 minus 5 is 1. And how would you rewrite negative 2 over 1? Negative 2. Now think about it. Should this line have a negative slope? Yes, because isn't it going down? Yeah, so that should make sense. Okay, now we have a slope. What's our next step? Look at the front if you need to. Yeah, you got to plug it into the point slope formula. So take a point. Does it matter which point? I don't care. Which one do you guys want to use? Sure, 5, 10. Take your point and your slope and plug it into point slope. Yeah, so that's y minus y1 equals m times x minus x1. People at home, do you see how we found our slope? Okay, perfect. So now people at home, we're just taking our slope and either point and plugging it into the point slope formula. So, somebody I haven't heard from yet today, help me plug this in. Brooklyn. Y minus 10, good. Equals -2 times x minus 5. Excellent. Y minus 10 equals -2 times x minus 5. Somebody else, what do I do now? I do distribute. Annalise, help me distribute. Yeah, so I'm going to drop down my y minus 10 equals -2x. A negative times a negative is a positive 10. Yeah, positive 10. Good. So plus 10. And then somebody else, what is my last step with this? Add 10 on each side. So I am going to add my 10 on either side. Yep. And I should get y equals -2x plus 20. And that is my equation. So put that on your line. Y equals -2x plus 20. Now let's talk about this. Let's see what this means. Wasn't my original number 19? That's very close to like my y-intercept, isn't it? That was like my first number. And this gave me 20. That's pretty close, right? So I would say we have a pretty good estimate here. Okay, so that's what it's saying this line represents. So I would say that's pretty darn close. All right, so what does the slope of the line of fit represent? So remember, you got to think of it, if this was you, if you were dealing with this, if you are selling DVDs or you're selling this game, right? What does that -2 mean for you? First of all, it's negative, right? So something's going down. What's going down? We talked about what this graph means. The sales are going down. How much are they going down each week? -2, but to what? Wasn't it in millions? So that means the sales are going down $2 million each week. Exactly. So means the sales, you could either say going down or you could say decrease, whatever you feel more comfortable with. The sales decrease. Yep, 2 million per week or each week, however you want to say that. Huh? I don't care. I'm really not that worried about it. Let me write this though so it fits. I wrote too big. Okay, sales decrease 2 million each week or per week, whatever you prefer. I just can't write small with this stylus. It just doesn't work. Okay, so then our next question is, what does the y-intercept mean? What do you think that is, Asia? So they're actually losing, technically they're losing 2 million each week. But this, remember, like if you rent something, didn't we have to pay like a booking fee and then like a per hour fee or something? Well, so this is actually your starting amount of sales. This is your starting amount of sales. So like this is how much you started with. This is how much it's going down each week. It's so always think of how I want you guys to think of it. Always think of your y-intercept as your initial value. Your y-intercept is always what you're starting with, right? In the previous problem, that worker was starting with -$4. This time you're starting with plus $20 million. Whoa, me too, right? I want that. So this means they're starting with 20 million in profits and it's going down 2 million each week. So again, your y-intercept is always your initial value and your slope is like the change that's happening each week or each day or each hour. Huh? Yeah, exactly. So yeah, so this is the starting value for sales. So starting value for sales. I don't know what's happening with my device today. It's very glitchy with my writing. Okay, so guys, one more thing, okay? So again, your slope is the change that's happening each week, each hour, each month, whatever's happening. Okay, and then your y value or your y-intercept is always whatever you're starting with, right? Your starting amount of money, your starting amount of DVDs, your starting amount of whatever, okay? All right.